Hey, welcome to another Science Masterclass with Mr. Salagaras. Today we're going to look at light and lenses. This is part of my Year 9 Physical Science course. We're going to break this into two chunks today, looking at light energy, and then we're going to look at how light interacts with different types of lenses. We're also going to look at properties of light as well. Okay, so let's look at properties of light to start off with. Light is a form of energy called electromagnetic radiation. It travels as a wave called electromagnetic waves. It looks like this image here at the top right. Where you've got light traveling in this electromagnetic wave where the electrical fields and the magnetic fields alternate. It's sort of similar but different to a sound wave, but we know that light travels as a wave. Okay. Light has specific frequencies and wavelengths, so when a light hits a surface it can do one of three things. It can either be transmitted through it, reflected off of it, or absorbed into it. The diagram on the right here shows this, where you've got absorption into the substance, substance, into the medium. We've got transmission of light into the medium here, and then we've got reflection off it, so bouncing off it like a mirror. Okay, we've got different materials here, so where you've got a transparent, translucent, and opaque material. These are just words that are used to describe what happens when light interacts with that type of material. So we say that something is transparent when all the light is transmitted through that substance, so a clear image can be seen through it. So an example of that is glass or shallow water. So something that is translucent, such as tissue paper or fingernails or frosted glass, we say it's translucent because some of the light may be reflected and light that passes through it is scattered, which causes a really fuzzy image. We say that something's opaque, like a brick or a piece of wood, because light is either reflected from or absorbed into that substance and no light is transmitted, so you can't see any image through it. So an object that releases or emits light is said to be luminous, such as the sun. A non-luminous object reflects light. So a luminous produces or releases light, and a non-luminous reflects it. An example of a non-luminous is the moon, which reflects the sun. Okay, let's talk about some reflections here. When light reflects off a smooth surface, such as a mirror, it undergoes regular reflection. So when it's off a smooth surface, it's a regular reflection. So a clear image is produced of this one here. You can see an example of this, of a regular reflection of the swan on the water. You can see a clear image that's being produced. The image that's underneath it, where you've got the lines and the arrows off a surface there, we use these lines here to represent how light interacts with a particular surface. When light goes in all at the same angle and bounces off at the same angle, we call this regular reflection. So this is diffuse reflection. When a light reflects off a rough surface in many directions, it's known as diffuse reflection. So the surface of an egg isn't perfectly smooth. It's got little bumps and lumps and stuff on it. You can see on this diagram down the bottom underneath the egg where you've got light rays coming in all at the same angle, then hitting the surface and then bouncing off in all different directions. That's called diffuse reflection. Now we're going to learn about the law of reflection. This is probably the most important part for you to understand. The law of reflection states that the angle a light hits a surface is the same as the angle at which it will be reflected off the surface. So let's say it again. The law of reflection states that the angle at which a light hits the surface is the same as the angle at which it will be reflected off the surface. There's a couple of important terms that we're going to look at that you have to know. An incoming ray is called an incident ray. So incoming incident. The angle at which the incident ray makes is called the angle of incidence. We represent this here with an I. The reflected light is called the reflected ray, which makes the angle of reflection, represented as R, and the imaginary line that makes a right angle with the surface is called the normal. We're going to look at a diagram to help you make more sense of all these terms here. The angle of incidence, and this is like a summary of the law of reflection. The angle of incidence always equals the angle of reflection, so I equals R. Okay, here's this diagram I was talking about. So imagine you're shining like a laser or a light into a mirror. This is how you could represent it here. So the incident ray, you can imagine the source or the laser being pointed directly from there. The incident ray, the incoming ray, is shining onto the mirror and then is reflected off. as the reflected ray. The normal is that imaginary line, the dotted one there, which creates a right angle with the surface, which is the mirror. We've got the angle of incidence here represented as I and the angle of reflection. So according to the law, it states that the angle of incidence of a light ray is always equal to the angle of reflection. So those two angles between the normal and the incident ray and the normal and the reflected ray is always the same. Okay, a flat mirror like the one you have at home is known as a plane mirror. The image on a plane mirror is a reversal of the object in front of it. This is known as lateral inversion. So it's a little bit tricky to understand why that is, but this is what we call it. It's called lateral inversion. We're going to talk about refraction here. Refraction is when light travels from one transparent substance into another and is bent. So an example of this is like when you've got a straw resting in a glass, it appears to be bent. It appears this way because light was bent as it was traveled out from the water in the glass to the air. This is called refraction. You can see another example of that in the image next to the glass there, where you've got that incident ray coming into the glass. It bounces inside, or it's refracted inside before it leaves. There's a law that we're going to talk about, the law of refraction, coming up soon. So why does refraction occur? So a light travels at different speeds through different substances. This results in different amounts of bending or refraction as light passes from one substance into another. So the refractive index is a measure of how easily light travels through a substance. The higher the refractive index of a substance, the more light bends when it enters the substance from air. We've got a diagram here on the right here where a car that enters a pool of water on a road will slow down and its path will bend more towards the normal line. We'll talk more about this one here soon. So we've got different media here, or different medium, and the speed of light in different medium. So you can see the speed of light changes depending on what it travels through. So through air, we can see it travels quite a lot faster than what it does through a diamond. This here also has a relationship with the refractive index. So the refractive index of air is a lot less than what it is with a diamond, so we can expect a greater refraction to occur in a diamond than you would in the air. So light bends towards the normal when entering a substance of a higher refractive index, and light bends away from the normal when entering a substance of lower refractive index. On the right here, we've got a diagram. We've got the normal, which is the imaginary line which separates the surface at a right angle, which divides it. We've got the red line here, which represents the incident ray, and then the refracted ray when it passes through those substances there. When you've also got the angle of incidence and the angle of refraction here represented by the I and the R. So when you've got water and air, you got the light bends away from the normal when entering a substance a lower refractive index, and it bends towards the normal when entering a substance a higher refractive index. So you can see that on the first diagram of water going into air, it's bending away from the normal because water has a higher refractive index than air does, and the opposite is true for the diagram on the right. So when light is traveling from air into water, the angle of refractive index decreases, so the line comes more towards the normal because water has a higher refractive index than air does. A little bit complex to understand, but once you practice this and once you see it through a practical, it makes sense and you can start to understand this idea of refraction. There's one last concept we want to talk about called total internal refraction. There are three reflection situations that can occur. When light enters a substance at lower refractive index, such as from glass to air, it's refracted away from the normal. The second scenario is at the angle of incidence called the critical angle, light is refracted at 90 degrees to the normal along the boundary of the two substances. Or the third situation is when the angle of incidence is greater than 90 degrees, the ray is not refracted, it is then reflected like a mirror, and this is called total internal reflection. Here is We won't have a look at that one here just yet. We won't have a look at this one here. This is an example, total internal reflection here at the top, where you've got light not exiting but bouncing inside and out of a medium there. Okay, here's some other examples that you can look at as well. Okay, we're going to leave it at that for this one here before we look at lenses. So in the next video, we're going to have a look at lenses. I know there's a lot of stuff to cover in that. Make sure you go back, take notes, ask questions, like the video, subscribe to it, and make sure you watch it again if there's something that you missed. Hey, thanks for watching.